Ben Woodman Mathematics.
Hello and welcome. If you're looking at this video, I would imagine you understand the general idea of the Intermediate Value Theorem, but maybe you're confused about something like the way the solutions of the IVT problems are phrased. Whatever it may be, you've come to the right place. I want to clear up any confusion about this topic, so we'll start off with a basic explanation of what it is, then we'll do some practice. Let's say we have some function f. And it's on this interval 1 to 3. And we want to know if a certain y value is on this interval. So let's say we're looking for 4. If we find f of 1 and f of 3, then we can compare these to 4, and if 4 is in between these two, then we know that the value 4 is on this function. So there's going to be some c value here, such that f of c equals 4. So let's just say f of 1 here is 1, 2, and 3, 7. Since 4 is between 2 and 7, then we know that f of c equals 4 at some point on here. This may sound a bit confusing, but it's really quite intuitive because this function is taking some path from 1 to 3 up, so it has to cross 4 at some point. Now there are some functions where this rule doesn't work. So if we have a discontinuous function, for example, then there may not be a y value of 4 here because there's a cutoff, right? So it skips over 4. So therefore, for IVT to work, f of x must be continuous. Okay, now let's take a look at a problem where you need to use IVT. So this question asks, for the function f of x, which equals 3x squared plus 2x minus 5, is there a root on the interval 0, 2? So this is really just asking, is there some c value where f of c is 0? Because a root is just a y value of 0. So let's take a look at the first point here, 0. So at the start of our interval, the y value is 5, negative 5, because f of 0 is negative 5. Now at the end of our interval, f of 2 equals 11. So our function is increasing from negative 5 all the way up to 11 on that interval 0 to 2. So let's take a look at this graphically. We have a function which looks kind of like this. And at 0, we're at negative 5. And at 2, we're at 11. So that means, yes, there is some point here, c, where f of c is 0. Okay, so how do we justify this? So the way we phrase our answer is like this. By IVT, since f of x is continuous, and since f of 0 is less than 0, which is less than f of 2, right, because we have negative 5, less than 0, and 11, is greater than 0, then there must exist some c value such that f of c equals 0. Please note that I made a small error in my statement. I should have said, then there must exist some c value in the interval 0, 2 such that f of c equals 0. It must be clear that this value is in that interval. So this might look kind of convoluted, but it's really just saying that yes, there is some c value between these two where the y value is 0, right? Because it's between -5 and 11. Okay, there's also a worksheet attached, so if you need more help, you can go through those problems and see if you're doing it correctly with the key. Thank you for watching, and I'll see you in the next episode.